One of the key challenges for the businesses is maintaining the right amount of inventory because a high level of inventory can tie up cash while a low level may result in losses due to stock out. So, to solve this problem for the Canadian smartphone market, I have developed a model. What this model basically does is it forecasts the unit level sales for the top four Canadian brands on a monthly level. The top four brands considered are Apple, Samsung, Google, and Motorola. Now, before we get into the forecasts, let me get into the methodology for a bit. One of the most difficult things in forecasting is getting reliable data. And unit level data for these brands are behind a paywall. Therefore, I had to use a workaround. Canada doesn't manufacture smartphones. So I looked into import data through HS Code, but the import data was incomplete for the recent years and wasn't enough alone to signal seasonality. So I refined it further using Google Trends data. Statistically derived lag was used on both the import and the Google Trends data. Then the data was upscaled to match the actual yearly sales in Canada, and market share was applied to find unit level sales data for each of the brands. Then the data went through a rigorous pipeline of pre-processing, and 8 different machine learning algorithms were tested on this. And the best models for each of the brands were chosen separately based on their performance on unseen test data, stability across periods, and the ability to find patterns. This scoring method was used. Now let's look at the actual forecasts. This chart here gives us a clear picture of the upcoming trend, and the table summarizes the yearly change for the brands. But we need to dig deeper to understand how each of the brands perform on a monthly level. This tab here shows us the forecasts on a brand level breakdown, and these are the confidence intervals, and these are the actual forecasts of the model. This chart here shows us the forecasted values and the possible upper and lower range for the phones. And the model is 80% confident that the value will fall within these lower and upper bounds and the percentage of this range, the actual forecast. And finally, this table here actually shows the forecasted values for the four brands on a monthly level side by side. Now next, this tab lists all the models that were used, their brief introduction, strengths and weaknesses. It also shows the used models error metrics for the specific brands, and it also shows this graph to visually analyze how each of the models error metrics are compared to each other. And it also uses a small breakdown of why the particular model was chosen for the particular brand along with its aerometric scores for the model. Now that's all technical details. How does this model actually stand out from a generic forecasting model? Well, it gives an option to adapt to future uncertainty. Future variables may change. 2026 may not be steady. Like, let's say, what if the inflation rate is 50% higher than the one predicted? Or what if Apple launches its phone on January and October? We can see if both of these things happen, both the demand and the growth will actually decline. Now, how this model does actually bring value to businesses? It actually gives business level insights for the managers to act on. This chart here shows the average bias and directional accuracy of the model. Bias tells us, on average, if the model underpredicts or overpredicts. And directional accuracy answers the question of all the times the model says the sales will go up, what percentage of times the sale does actually go up. Here for Apple, the model is right 9 out of 11 times, and for Samsung, it's right 7 out of 11 times. This table here shows how the model actually adds value compared to the baseline models. Four baseline models are compared. One that assumes the last known value will stay the same for the year. Another assumes the sale of the last year's July will be the same on this year's July. And the other two are 3 and 6 month moving averages. And the best of them was compared against the machine learning models, which was Gaussian processes in this case. And this machine learning model actually beat the baseline models both on error matrix, bias, and directional accuracy. Now, this is the most insightful section for managers. It shows the overstock and understock risk according to the confidence interval of 80% for the model, that the model is actually 80% confidence that the lowest possible demand will be on this range and the highest will be this range. And it also recommends a safety stock, which is actually 50% of the stock of risk. And this buffer is actually 10% of the total forecast. And finally, this model gives us brand specific recommendations and strategies that should be used. It tells the recommended strategy for the brand, the amount of safety stock to be maintained, risk profile, forecasting confidence, and what the peak months are. Finally, this also gives us the option to download the forecast as a CSV or an Excel report to analyze it further. These forecasting tools moves away from traditional tools in its transparency, adaptability, and operational insights. It tells the managers what the forecasts are, how we derived it, and how confident we are in it. It also allows them to adapt to future changes in the variable and test different scenarios. And I'm also providing the link of the app along with my repository link on the comment box. That's all from me. Have a great day and thank you.